Okay, so went ahead and decided to work just with the challenge student today and work separately with the natural students a little bit later. Went ahead and gave her free reign of doing her work, and now we are going through and checking her work and just making sure everything's squared away. So I have her work that she's done, the chart from week 3, charts from week 1 and 2, and then I have the companion open on my tablet. We have already reviewed page 1, and we did end up looking at on the companion. You can go to this cover page has your math map on it, and if you select any of the dimensions, it will give you information on that specific dimension. So since we've transitioned out of 0D from the last 2 weeks and into 1D for this week, I went ahead into the companion and selected first dimension, and we read that section so that we had some context as we were looking at our review. Then I went into the week that we're actually on, and we are looking at the work now. So, like I said, we already did page 1. Looking at page 2, we talked about linear scales, and we were comparing whether the lengths were equal or not equal. I'm going to go ahead and get the solutions for this week, just to double check. Right, and the linear scale equals 1 inch. This is an integral symbol, so 1 integrated equals 1 inch, the length of that. Good deal. All right, simplify and label the midpoint where AM equals MB. So keeping in mind that we are talking about comparison, and we are speaking about number lines. Simplify and label the midpoint where AM is equal to MB. Well, labeling the midpoint is easy. So go ahead and label the midpoint on that number line that is in between A and B so that AM and MB are equal. Good. Now we have to figure out the value of AM and MB. And we're going to do that.
They're both negative.
Where's your whiteboard? Your little, the trivia table.
Okay, here, I found it.
Do you have a whiteboard marker?
Yeah, man.
Right. Is that the whiteboard? That's not the whiteboard. That's Latin.
Have an extra one.
Yeah, we do.
Okay.
Okay, so simplify and label the midpoint. So if we're working m x to base 1 plus x to base 2 over to 97 plus negative 97 plus negative 65 divided by 2 equals. Okay, so this is our formula, right?
Mm-hmm.
And they already plugged the numbers in for us, saying that x1 is equivalent to negative 97 and x2 is equivalent to negative 85. So what is negative 97 plus negative 65? Mm-mm. Remember, when we have two negatives, it's actually positive.
Oh,
So we're just going to treat it like addition. Okay. However, it does keep its negative
oh, wait,
symbol. Yep. So now up here, we're going to convert our fraction to our solution, which is negative 162
Negative 162
over
over
2.
2.
Okay, so what does that over tell us we need to do? The fact that
It's
in a fraction.
Division.
Yeah, division.
162 negative 2. 8, which would be 16, minus, which would be 0, bring down the 2, yeah, which would be 0.
Okay. Good. So the solution for m is equal to what?
Negative 81.
Yeah, because this equals negative 81. So let's transcribe our answer to our sheet.
Negative 81.
All right, simplify the midpoint of the intervals. So I think we're using the same system we did right here, where it's giving us our formula and then plugging it in for us, and we're just carrying it down to a reduction. So if we maintain that, then what would 1.1 and 1.9 be?
Well, it would be
How would we write that into
1.1 plus 1.9 would be 10. Would be 30.
What's your decimal?
Oh wait, 3.0.
3.0. So now, what do we do next? What's our next step? We have our top done. Do we just forget about our bottom? The 3.0 has to be over 2, right? So to show our work, we're going to copy this into the book and say 1.1 plus 1.9 over 2 is equal to 3 over 2, which is reduced to what?
3.0.
Nope.
Wait, no. It's
How do-
reduced into
We're trying to get it to a decimal format. How do we change a fraction to a decimal?
by dividing.
Yep.
So we would do 3.0 divided by 2. 2.
How many times does 2 fit into 1? Or into 3, rather?
One time,
Giving you
which
the answer.
would be
Yep.
2 minus
Bring down your
equal
scale.
1, bring down my 0.
How many times does 2 go into 10?
5, which would be 10 minus, which is 1.
Okay, so
So
3
it would
over
be
2
1
reduces 2.
Wait, Mom, that would be like 30 minus half of it, which would be
Yeah. It's just taking something and splitting it into 2
1.5.
numbers. Alright, do the same thing with these 2 numbers.
okay. 40 plus 20 is 0. That would be 6. Okay. Now that would
You could actually do
be
this
over
straight.
2, which would be 30.
Make sure to show your work, not just the answer.
Oh, yes. 40 plus 20
Over.
over 2
Mm-hmm.
equals over 2.
Which
So-
reduces to, what's 60?
Which
and 2 groups?
reduces to 30.
Good. Do it with the last two numbers.
Okay.
You should be able to do it right in the book unless you just want to use the whiteboard. Baby's up.
10, 3, that would be 30. So over 2. So we would do 25 plus 5 over 2 equals 30 over 2, which equals 15. Mom, I'm ready when you're ready.
Alright, looking at our next section, plot the 1D notations. Most of that's just tracing, so go ahead and work on that. Yeah, I know, right?
He's much happier after a nap. Yeah, it's alright. Mom.
Yep. The last two
Would
you
they-
actually have to do on your own.
It would be the circle, trace, and then the filled-in circle.
Yes, that shows us that. So the one on the left should be open. B, Y. Why is that plot of 1D notations? Oops, sorry.
No, wait. This
Come on, page 1, hold on. Page 2.
Mm-hmm.
Here we go. Let's watch this video.
And our third section from the top of page 2 from lesson 3, we're asked to plot the 1D notations. And so notice a lot of this is tracing just to help really emphasize what we're doing. So in the first one, we're told that A, our value A, is equal to point A.
No.
Those are plotted together. Label them, both of those. A greater than 0, A greater than or equal to 0, so this is going to be a closed circle. Greater than points to the right, that's my interval A. A less than 0 is an open circle with an arrow to the left. And that's my A there. On the right-hand side, we have E is less than or equal to, so it is a closed circle, and A and then less than pi, so that will be an open circle, and we're including all the values in between. So that is all the values from and including E up to, but not including pi. So now we have two that we're going to fill in, and so notice we have not equal, so I'm going to have an open circle at the square root of negative square root of 11, and we have an or equals, so we're going to have a closed circle at the square root of 11. A is between those two values. And then I have that these are both not equal to, so they are going to be open circles. And again, A is between A and B.
Okay, did that help?
Will
So
he
the
eat
open
non-bread,
circle-
Mom?
He might. I'll worry about that. So the open circles mean what?
So the open circles mean pi?
No, the open circles mean not equal.
Not equal. Because pi is not equal to e negative 11. The square root of negative
Negative 11.
a negative 11 is not
The
equal.
negative square root of 11.
The
sorry.
negative square root of 11 is not equal to the square root of 11. And a is not equal to b.
So verifying the solutions. We have open, closed, and open, open. Good.
She was like writing it down in the video,
nice.
so I got it.
All right. 1 yard equals how many feet?
There, wait.
That's a yardstick. How many feet?
No, which one? The first one?
Okay, hold up. Come sit.
It's 36.
Sit. We're going to go back to foundations. 2.54 centimeters equals 1 inch. So it's not 2.5. It's 2.54. No, 0.54. It's not a fraction. It's a decimal.
0.54.
But you wrote 5.4. 2.54.
2.54.
2.54 centimeters equals 1 inch. 12 inches equals 1 foot. 5,280 feet
So,
equals 1 mile.
5,280 feet equals a mile.
How many feet are in a yard? If that's a yardstick.
36.
36 inches. How many feet?
Look.
What is 36 divided by how many inches on a foot?
12.
So what is 36 divided by 12? Skip, count your 12s.
12, 24, 3.
Yeah. 1 yard equals 3 feet. Lord have mercy. All right. Meter equals 100 centimeters. 1 centimeter equals 10 millimeters. 1 kilometer, kilometer. How many is in a kilo?
Kilo 1,000.
Yes. Good
So
job.
it would be.
So you just referenced your I3 page to help you with that one.
So it would be 1,000.
1 kilometer equals 5/8 of a mile. And then the flexion or the converse of
So that
is
means
8/5. 8 over 5. Does it say anything about that on? Let's look at the lines and parts of line, comparison laws. Here. Here.
okay.
So in your chart C33,
wait.
it has your.
So if this is 8 for 5 miles, 8 kilometers for 5. Oh wait, 1 kilometer equals 0.621 miles.
That's the fractional
okay.
representation of it, so you could do either
Is
one.
Mr. Jeffy?
I don't know. Okay, simplify the compound measurements. The only thing you're doing here, they basically did all the work for you,
So we just have to add it?
and so you're just doing the last.
So that would be
So
20 centimeters. Well, 2 centimeters.
this is 2 kilometers
Mhm.
plus 2 meters plus 2 centimeters equals how many centimeters? Okay, so how many centimeters are in a meter?
Centimeters in a meter. 10. Well, no.
Centi.
Sorry.
Century.
Be back here. Centi is 0.01.
Okay, think of think of how many cents are in a dollar, how many years are in a century.
1?
1 year is in a century?
No. Well,
100.
100.
Yeah, 100 cents in a dollar, 100 years in a century.
Yeah.
How many centimeters are in a meter?
Yeah.
How many centimeters are in a meter?
100.
100. And how many meters do we have here?
200.
We have 2, so it's going to be 200, right?
And then that's
Okay.
going to be 2.
How many meters are in a kilometer? What was kilo?
1,000.
1,000.
So that would be 2,000.
So this is 2,000. But that's only 2,000 meters. We still want centimeters is our final unit. So if it's 2,000 meters, and how many centimeters are in a meter?
100.
100. So we need 2,000 times 100, right?
Times?
Yeah. Where's the marker?
Okay, I got it. Okay, this will work.
2,000.
2,000.
100 times. Do you remember the trick for multiplying by things that end in 0? Nope. Yeah, kind of.
That's how Miss Nicole taught.
Yeah, I don't know how that works though. So.
Plus 0, 0.
Yeah.
So when you just throw them out the end and then you don't worry about it.
Don't like it. I don't understand your crazy math. That's not it. Because when you bring down, why did you bring down? I'm confused. If you add it, don't you bring down the 1?
We're adding?
You wrote an addition symbol.
Times.
Yes, it should be times. This silly girl. She doing math mama didn't know. Yeah, whenever you're multiplying by something that starts with a 1 and ends in all zeros, you just tack the zeros onto the end. So it's literally just going to be that. You don't even got to worry about all that. So how many centimeters are in a kilometer?
200.
Well, 100
2,000.
are in 2 kilometers. So we're going to take this. But do you see how the comparison that we're working on is that we have to convert our units to be congruent with each other?
Yes.
So now you can add it together.
Okay. So
200,000 plus 200
hold and
plus
200. 2.
Okay.
Centimeters.
Ooh, writing ratios. 5 inches, 15 inches, 6 miles.
I just copied it because those were like that, so I just did it.
Oh, because our scale is 1 inch equals 1 mile. So, yes. Good. All right. Simplify.
And then all that equals 1.
The green box signifies a value of 1 whole. Anything divided by itself equals 1. So that's 1 whole. Par over par, 4 over 4, 6 over 6 is 1 whole. And then 2.54 centimeters. Again, we're seeing this comparison between units, but they equal 1 whole. Why are you throwing that on the floor? All right. Is 0 over 0 equal to 0 or 1, or is it undefined?
1, because it's itself.
It could be either based on its,
So undefined?
well,
It could be either.
I think it could be any of them based on what it's kind of a define your terms situation.
Well, I would say 1 because this one says anything to itself equals 1.
It could be for sure. The circumstance, I think, of what domain you're in would help, or not domain, maybe domain, definitely dimension.
Which means we're
would
in
affect it.
complex.
Yeah.
So
All right.
what does that mean?
Let sleeping dogs lie and move on. Boil and tea is closest to that. Yep. Good. Yes. 100 degrees Celsius.
Yeah, I
Whoa.
looked on that.
Hold up.
What?
You missed one though.
It's 30.
It's 30 wood. It's not 30.
Oh, F.
Hey, your head's like really in the weather.
Sorry.
Not 30 Fahrenheit. No, it's not labels. It, so in, I don't know what they called this earlier. Hold on, they had a word for it. It was like, I've always called it the imperial system. Anyway, it's not metric. In the non-metric system that America uses, our numbers don't end in 0 like pretty metric system.
It's 32.
Yeah. Alright. And the domain for both of the thermometer labels are
This one.
what domain?
This is naturals, which means.
They're both no.
Oh, they're both naturals.
They're both naturals. They're both within the regular natural numbers.
I did my pretty in.
Ooh. Alright. Jesus, we will lose. Label the quarters and eighths on the big inch.
Big inch.
So we're labeling our quarters and our eighths. So we have 1/8 equals 0.125. 1/4 equals 0.25. What comes after
25.
that?
Half. No.
It's actually hell. Check chart 3-2.
Oh. Okay.
So you have 1/8.
That's 3/8.
No, you have 1/8, and then you have 1/4, and then what's the next?
5, 6, 7.
Is it?
Right here.
1, 2, 3. I'm just trying to get my bearings. Hold on. 1, 2,
1/8,
3.
1/4,
1, 2, 3. Yeah, you're right.
3/8. Well,
Yeah, 3/8.
be 3/8.
Yeah. Because we're talking about eighths.
Means 1/2. 5/8. 3/4. And 7/8.
And what are their decimal equivalents? So for 1/4 you have 0.25. For 3/8 you have
0.375. 0.5. 0.625. 0.75. 0.875.
Alright, good deal. Write our fractions, color the matching segments of the circle. So you have the decimal.
3.
We want to write the equivalent fraction, which again is on the chart if you need it. Whether it's, you want to use that or this.
But wouldn't you do 3?
I think you would.
Okay.
Nope, that's half. We only want what?
1.
Look here.
2, 6.
Yeah.
Well, I said you want to do 3, and you're like, yeah, I think that's right.
No, did not. I meant for you to color 2. Because that's 1/3. Alright, and then what's your fraction?
0 over 3. Wait, no. 2, 6.
Which is equivalent or reduced to what? Because you can divide both of those by 2.
36.
What's 2 divided by 2?
4.
Not 2 times 2. 2 divided by 2.
1.
Yes. So your numerator is 1, and what's 6 divided by 2?
Oh wait, 6 divided by 2.
6 divided by 2? 6 split into 2 groups.
Oh, 3.
Okay. Alright, next one.
50%.
Okay, hold on. Hold on. No, it is wanting you, okay, I had you reduce it, but it is wanting you to write the fractions as shown by the pie chart. So do 2/6 instead of 1/3. 1/3 is the correct reduction. but that
So
one I did
it did want me to write from
Yeah,
there.
so 1/6, 2/6, what's next?
Oh, okay.
Why?
Because it says right there.
No. Where? How many pieces do you have?
Oh, wait. Oh, right here.
Mm-hmm.
6.
Oh my goodness. Do you need more fancy stuff?
Okay. Yes, I do. Okay. So,
Okay. Complete the table.
Oh, right,
Prefix,
I
symbol,
forgot to do
power, and
this.
decimal.
2/4.
No, it should not be forced. How many pieces do you have?
Oh wait, that's
The numeral shows you how many pieces are shaded. The numerator shows you how many pieces are shaded. The denominator shows you how many pieces there are to possibly have.
that.
Yes.
Which means I slide everything over.
No. Nope, we're not on quarters. We're on 6.
Okay. No, right here, which would be 4. Because it should be 1, 2, 3, 4, 5, 6.
Yes. All right. Complete the table. Prefix, symbol, power, decimal. Your symbol. It's right there. The charts have the key.
Symbol. Key.
Hey, Mimi. Darby, no.
What was Mimi saying? Wait.
Is that Emily? Yeah.
Would that be kilo?
For kilo?
Oh, hold on. Symbol. I'm
Kilo.
Yes.
Your symbol is K. Lowercase k. Your power is
And the egg.
your power is 10 to the third,
Yes.
and your decimal is what? Your numerical value. Okay.
Which
Well, that had
means
to-
that would be 10 and then there.
Check. Yes. Right. Write the equivalent temperatures again. You need to
I
edit
didn't
that.
know Kevin.
Kelvin.
Kelvin.
Okay. Did you reference your chart?
No.
Right. And fix your. Very fun.
It's to help me remind.
Is to help you what?
It's to help me remind for linking groups.
Ah, linking verbs. Very nice. Good deal. Thank you. finish your work, please?
Would I do this? Yes.
Okay.
Okay. Wait.
First, fix your freezing point.
Which means this would be.
No, don't guess. Hey,
50.
boiling point of water. So literally written out. Mm-hmm.
Boiling point. 7, 3, 15. Freezing would be 2, 7, 3, 15.
Okay. Good deal. All right. Last page for today. Yes. Yes. All right. So on this number line, all you're doing is sketching the symbolism. So you're going to sketch, what does it look like when you sketch a line? What does it look like when you sketch a ray?
What?
No, on the number line, not above it.
On it.
Yes.
Yeah, but then you won't be able to see it. Oh gosh. That's what this is saying. This. Yeah.
Oh, we found it.
I think it's just supposed to be on the line, not like taking it over. But that's fine, we'll go with it.
Yeah.
All right,
Well, there was a number line, so I did that one.
it's fine. All right. The limit of 9 equals 9. The limit of 9 as x approaches 9 is 9, so that's how we write this, right? The limit as x approaches, well, that's how we write it. The limit as x approaches 9 is 9. So if the limit of 7 is 7, then the limit of 7 as x approaches 7 is 7. Good. Find your patterns. The limit is 12.8, then the limit of 12.8 as x approaches what? 12.8 is 12.8. Good. All right, we're just simplifying here. What do we have? Do your PEMDAS. Parentheses, exponents, multiplication, division, addition, and subtraction. What do we have here?
Please, my dear, I'm sorry.
Yes.
0.
Okay, what is this function? What is 3 open parentheses, 5 closed parentheses telling you to do in a mathematical operation?
Yes? No. Turn it into a decimal.
No. It's multiplication.
Multiplication.
Whenever a number is directly next to a parentheses, that's the implication for you to multiply. So 3 times 5 is what?
3 times 5 is 15.
Plus 0.
15.
Okay. So then, here we go again. It looks different, but the function is the same. 3 times 5 is
15.
plus 0. Okay, what about this one?
Okay. 17 and 17.
All right, compare hops to vector notations. So just pay attention to how the hops are rounded and they go in between, whereas the vectors are just straight and they continue.
Mm-hmm.
Okay. Write 10 to the n if the power is positive, or 1/10 to the n if the power is negative. So this power is positive, ergo we wrote that. This is negative, so we wrote it as a fraction. Positive, wrote it as a whole. Fraction, wrote it as a fraction. Or negative, wrote it as a fraction. So this one is positive, so we write it as a whole. Negative, so we write it as a fraction. Positive, write it as a whole. Negative, write it as a fraction. Good. Whole fraction, whole fraction. Good. All right. This is a completing the place value expansion.
I did.
Okay, so what is how do we write out in expanded form 10 to the second power?
Like it says, 2 times. I needed help with addition.
We're working on it. 10 to the second power. Let's look through our charts. All right, here we go.
Right here. It'd be 2 in.
Hold on.
Right.
I see what you're saying. I don't see the connection. So give me a minute, please. I will figure that out when I'm done with school with Ava. Okay. I don't know the scientific or mathematical way to explain this, but to me the little number just tells you how many zeros. So you have the 1, so how many zeros are you supposed to have?
2.
Yes. I don't know why I know that. I just do. So
20, 50.
but how many? Yeah, because you're supposed to have how many zeros?
1.
Yeah, so where's your 0? If you're supposed to have 1, where is it? No, we're trying to get rid of the exponent and change it into multiplication. My love. No exponents allowed. Write it without exponents. How do you write 10 to the first power? Yes, thank you. Because anything to the first power is itself. No. 9 times 1 is not 90. 9 times 10 is 90.
9.
So, and then our decimal sum, or the total, would be what? 259 to what base? Yep. Okay. And
Because in 0D, you're just copying from this is all filled in and then you just copy.
okay. All right. We have completed all 4 of our worksheets, and we have checked them using the charts, using the solutions, and using the companion. Good job.